welcome to this session. In this session, we are going to discuss about go back and ARQ. The go back and ARQ available in the noisy channel. Already we have discussed about noisy channel and noiseless channel. Simplest protocol, stop and wait protocol and stop and wait ARQ. We have discussed in the previous session. Now we are going to discuss about go back and ARQ. In the go back and ARQ, there are several parameters we are going to discuss, or environmental variables we are going to discuss about go back and ARQ. Number one is sliding window. Before getting to the sliding window, why it is needed, why it is required, that we will discuss first and then get into the sliding window. You just recall the previous ARQ, stop and wait ARQ. In stop and wait ARQ, what we are doing, we are transmitting one frame and then stop the transmission and waiting for the acknowledgement. If the acknowledgement is received correctly, then only sender transmit next frame. So, at most in stop and wait ARQ, only one frame is transmitted. Let us assume the situation 100 kbps speed supported in your system or in your network. It means bandwidth allocated is 100 kbps. You are sending only 1 kbps, let us assume. Let us assume you are sending only 1 kbps, but supported bandwidth is 100 kbps. Then just calculate what is the utilization percentage. So instead of sending 100 frames at one time, we are sending only one frame. Obviously, we are sending very less frame. So utilization percentage is very less. The bandwidth utilization percentage is very less in this case, even though our bandwidth provide enough number of frames support. So in order to avoid this, and to improve the bandwidth utilization, go back and ARQ is introduced here. In go back and ARQ, instead of sending only one frame, we are sending more number of frames to the other end. From sender to receiver, more number of frames are transmitted based on the bandwidth support and the number of bits allocated for the sequence number. Based on these two factors, we are able to send more number of frames in go back and ARQ. So that if more number of frames allowed to send, if more number of frame is allowed to send, then we need to change slightly certain parameters like sequence number, control variable and sliding window. These three parameters or attributes are changed here in go back and ARQ. Sliding window is not exist in the stop and wait ARQ. This is the new concept introduced in go back and ARQ. What is mean by sliding window? Sliding window is a window, right? Sliding window is a window which includes certain number of frames to be transmitted, and the window is slide over. The window is slide over whenever it receives acknowledgement for certain frames. Whenever the window is slide over, certain number of frames excluded in the left and certain number of frames included in the right of the window in order to maintain the window size as fixed. Let us assume the window size is 15. You are receiving. It means window size is 15 means we are possible to send 15 frames. So that starting from the first frame, 0, 1, 2, 3, 4 up to 15 frames continuously able to transmit. That is possible in go back and ARQ, right? Then while we are sending the frame, the receiver sending acknowledgement for certain earlier frame, then those acknowledgements are received, and how many frames it receives acknowledgement, such number of frames, the window is slide over to the right. Whenever the window is slide over to the right, left to this window certain frames are excluded. How many frames to be excluded means how many frames it receives acknowledgement, such number of frames excluded. How many frames included, how many frames excluded, such number of frames are included into the window in order to maintain the window size as fixed. I'll show the sliding window. I'll show the sliding window here. See, this is the sliding window. This is the sliding window. In the sliding window, as I said previously, certain number of frames are exist. Certain number of frames are exist here, 0 to 14. I mean 15 frames are available here. So 0 to 14 it is. See here, 0, 1, 2, 3, 4 up to 14. So 0 to 14, totally 15 frames are included here. What is the meaning of that? At the same time, one after another, we are able to send 15 frames. And then in orange color, certain frames mentioned here from 0 to 6. Those frames are transmitted successfully. Those frames are transmitted successfully and waiting for the acknowledgement. Sender is waiting for the acknowledgement. And then from frame 7 to 14, right? From frame 7 to 14, yet to be transmitted, but we are able to transmit. We are able to transmit, yet to be transmitted. Those frames are indicated as white color. So, this particular diagram specifies what is the case in the system before sliding, sending window before sliding. As I said previously, certain frames are available left to the window. Certain frames are available left to the window. Those frames are already acknowledged. Certain frames right to the window available. Those frames are not able to transmit. We cannot send those data. Right? Whenever those data is included within the window, then only we are able to transmit those data. And then the second diagram here indicates here after sliding, what is the case of sending window at sender? See here, previously 13, 14, 15 available left to the window. Now, apart from 13 to 15, 0 to 2 is available to the left. It means after this frame, after the first window, the system receives the acknowledgement for 0, 1, 2. It receives acknowledgement for frame 0, 1, 2. If the sender receives acknowledgement for any frame, then immediately window slide over to the right, and how many frames receive acknowledgement received, that frames excluded from the window. So 0, 1, 2 excluded. I told that the window size is always fixed, so that 3 frames excluded, so that 3 frames included within the window. According to this slide over, the SF variable, control variable SF is reset from 0 to previous first frame to new first frame. 3 is new first frame, so SF indicates to 3, right? And then I want to tell you the control variables. There are 2 control variables are present in sender side, SF, SN. In the previous ARQ, stop and wait ARQ, we are maintaining only one variable S. Because we are sending at most one frame, right? We are sending at most one frame in stop and wait, so that we are using only one control variable. Here more number of frames are transmitted, so that one control variable is not enough to maintain the sending sequence number, so that 2 control variable SF, SN available here. SF indicates first outstanding frame, SN indicates next frame to send. So these are all the things you should remember regarding sliding window at sender in Go Back and ARQ. Sliding window at receiver is only one control variable RN. At receiver side only one frame comes under expected frame. Only one frame comes under expected frame. Which frame is expected next, that is available within RN. Once it receives the expected frame, once the receiver getting the expected frame, then window is slide over, previous frame excluded, one new frame is included within the window. So 3 received acknowledgement are got acknowledged. Next frame is included here, frame number 4 is included in RN. we have discussed about the sliding window. Next we are going to discuss about sequence number in go back and ARQ. Because I always compare this method with the stop and wait ARQ, then only you are able to understand the concept clearly. So that the sequence number concern, I just go to the previous method, stop and wait ARQ. In stop and wait ARQ, we are sending only one frame at most, so that the sequence number is 0 and 1. Only two sequence number available because we are sending only one frame at most. But here more number of frames we are going to transmit, so that the two sequence number is not enough. Suppose you are sending 14 frame or you are sending 15 frame, then we need 15 sequence number instead of 1 or 2 sequence number. So the sequence number in go back n, that range is changed here, and then it uses 2 power n. The sequence number in go back n is 2 power m, where m is the number of bit allocated for sequence number. The number of bit allocated for the sequence number. See, already I told that there are several protocols available in the data link layer. Several protocols available in the data link layer, for example, Ethernet, token ring, token bus, and so on. All those protocols define the sequence number field. Define the sequence number field, in which how many bits are allocated for the sequence number? 3, 4. 4 bits allocated for the sequence number. 5 bits are allocated to the sequence number. If 3 bits are allocated, then 2 power 3 equal to 8. So we can generate 8 sequence number for 3. If 5 means 2 power 5, 32 sequence number, 32 sequence number can be generated and utilized for 4 concern. 16 sequence number can be generated and utilized in the system. And then another point you should remember regarding sequence number is, we are using 8 sequence number. Actually it starts from 0 to 7. Here if it is a 16, 0 to 15, the case sequence number will be created and managed. Here 0 to 31. And then control variables also we have discussed already. Sender side SF, SN control variables available. Receiver side RN control variable is available. And then come to the acknowledgement, right? Come to the acknowledgement. And one more thing I want to tell you regarding the control variable and timer. For each and every frame transmitted, the sender starts the timer as we have in stop and wait ARQ, right? In stop and wait ARQ also, we are starting the timer for each and every frame. Similarly, in go back and ARQ also, we are starting the timer for each and every frame. Once the frame transmitted successfully, it is expecting the acknowledgement within the stipulated time period. Within the stipulated time period, it is expecting the acknowledgement. Before timer expires, if it receives acknowledgement, then the timer is closed. Then the sender transmit next frame and so on. Similarly, here also the timer is started and waiting for the acknowledgement. Next one, acknowledgement concern. If the receiver receives the data correctly, then send the positive acknowledgement. Otherwise, if the receiver is not receiving the data correctly, it may be corrupted or lost. Not receiving correctly, then no acknowledgement is transmitted, and simply the receiver kept in silent mode. Next one, operations as like stop and wait ARQ. In go back and ARQ also normal operation. If frame is lost, then what happened? If acknowledgement is lost, what happened? Those operations we are going to discuss about in go back and ARQ. And then sliding window we have discussed, sender and receiver sliding window, and next we will see the designing components of go back and ARQ. The designing components of go back and ARQ. See, as I said previously, the sliding window is defined at sender as well as at receiver. At receiver, only one frame is included within the window, so that here only one window is mentioned. In the sender side, there are several frames included within the window. That is purely depends on number of bits allocated for the sequence number and the window size. According to go back and specification, the window size is 2 power m minus 1. 2 power m minus 1. Suppose 3 bit, right? Suppose 3 bits are allocated for or m equal to 3 means sequence number is 2 power m, so that 8 sequence number generated and window size concerned 2 power 3 minus 1 equal to 7. So according to the specification, 2 power m minus 1 frames included within the window. As I said previously, SF indicates first outstanding frame, SN indicates next frame to send, SN. Come to the sender side. See here there are 3 layers involved in the communication. As I said previously, sender side, data link layer, receives the data from the network layer. The related event is request to send. The request to send event is initiated by the network layer to data link layer. Whenever the data link layer receives the event notification from network layer about data to send, immediately the data link layer executes its algorithm and generate the frame or construct the frame. The frame is transferred to physical layer and transferred through medium and it reaches receiver. Right? Come to the receiver side. The frame is received by the physical layer. Right? Physical layer, immediately this event is notified. Whenever the physical layer at receiver receives the acknowledgement, then acknowledgement arrival notification is given to the data link layer at receiver. Then data link layer at receiver executes its algorithm and extract the data from the frame, and data is delivered to the network layer. If it receives, the receiver receives the frame correctly without any error, then it send acknowledgement frame. The acknowledgement frame transmitted over the medium and it reaches sender. Then immediately this event is notified. Arrival notification of the acknowledgement given to the DLL. Immediately the data link layer executes its algorithm and extract the acknowledgement frame from the incoming data packet. Once it receives positive acknowledgement, then it concludes that the previous frame is successfully transmitted and it is taking care of the next frame and so on. By this way, the system will work in go back and ARQ. These are all the designing components of the ARQ. See, the sequence number concerned 2 power m minus 1 sequence number will be used. What is the reason for this? We will see later. And then next one, why we are maintaining the window size as 2 power m minus 1 instead of 2 power m. See, we have 2 power m sequence number. But we are not maintaining that much window size. What is the reason for that? See, here this is the worst scenario, right? This is the worst scenario. Let us say the window size is less than 2 power m. What we assume? Less than 2 power m means 2 power m minus 1. 2 power m minus 1, which is nothing but less than 2 power m. Okay. In this case, see 0, 1, 2, 3 frames are included within the window. 3 frames are included within the window. SF is 0, SN is 1. And then receiver expecting 0th frame. So frame 0 is received correctly. And then it sent the acknowledgement, but acknowledgement is lost. Once the receiver sent positive acknowledgement, then immediately the receiver window slide over and next expected frame is 1. But sender side 1, 2 is available within the window, so that it transmit frame 1. The timer for 0th frame started here and then it sent frame 1. Expected frame is 1, received frame is 1, so successfully it is received. Successfully the frame is received and receiver window slide over 2 is included within the window. And the acknowledgement, this case also, that's why I told that this is the worst case. All acknowledgements are lost. That is our assumption. In the worst case, how the system behaves. See, the second acknowledgement is also lost. And then 2 is also available within the window. So frame 2 is also transmitted. See, frame 2 transmitted, expected frame is 2. So no out of order sequence, it is accepted, send the acknowledgement is lost. And then Rn reset to 3, next frame is 3, next expected frame is 3. Here 3 is available outside the window, so that we cannot send frame 3. We cannot send frame 3 until we receive the acknowledgement for all 3 previous frame 0, 1, 2. See here, timeout occurred for frame 0. Timeout occurred for frame 0. Immediately SF variable is reset to 0 again. SN variable is reset to 0 and frame 0 is transmitted because the frame 0, previous frame 0 retransmitted here. Previous frame 0 is retransmitted here. Expected frame is 3, received frame is 0, so correctly discarded. Expected frame is 3, received frame is 0, so it correctly discard the frame. It is not the expected frame. Frame is received in out of order sequence, so system correctly identifies that. Come to the other side. If you are not maintaining the window size as 2 power m minus 1, then what happened in the system? See, all 3 frames as like the previous model, we are sending all frames within the window. Now the window size is 2 power m. It means 4. Now window size is 4. Previously window size is 3. Correctly our system behaves, it exactly identifies the error. But here, instead of 3 frames, we are using 4 frames within the window. Frame 0 transmitted correctly, 1, 2, 3, all 3 frames are transmitted correctly because 3 frames included within the window. And then at receiver side, first 0, frame 0 received correctly, frame 1 received correctly, 2, 3, and then window slide over, it is available, receiver window is available in the 0 of next sequence, right? 0 of next sequence. This frame is not the previous frame. This frame 0 is next sequence frame 0. Come to the sender side. All 3 frames are successfully transmitted. Timeout occurred for the first frame. So immediately frame 0 is retransmitted. This is retransmission. It is expecting the next frame. But what is our identity based comparison? Frame 0, frame 0. So the receiver thought that it is the next sequence 0. It is the next sequence 0. So that erroneously it accepts the frame. So in order to retain or in order to manage the worst case of your system behavior, the system window size. The system window size in go back n is 2 power m minus 1. And then sender algorithm, go back and sender algorithm. What is the algorithm available at sender? How it is executed and what is happening we will discuss now. First window size is assumed as 2 power m minus 1. SF equal to 0, Sn equal to 0, first frame available within the window. Continuous process, infinite loop while true, and we are waiting for the event. Once the network layer at sender sends the event request to send, immediately this particular if loop will be executed. If first it checks before sending any frame, a check has been made. See the previous case. See here, before sending any frame, that frame is included within the window. We are able to send the frame only within the window. Those frames only we are able to transmit. Any frame outside the window is not possible to transmit, so that the check has been made here. Sn minus Sf greater than or equal to Sw. If it is greater than or equal to Sw, we are reaching the last frame available within the window. We cannot send further, so sleep conditions. Otherwise, we are in the middle of the window. So we need to transfer the data by using get data. We are getting the data from the network layer, and then the frame is constructed and store the frame. Why we are storing the frame means, if that frame is not received correctly, I mean if it may be corrupted or lost, in such case sender have to retransmit the frame. In order to give provision for retransmission, the frame is stored before transmitted, and then transmit the frame and increment the Sn, and then the timer is not running for the current timer is not running for the current frame, then start the timer. As I said previously, for each and every frame, we are starting the timer. See, this is the first case, frame sending event. And the next one, if the sender receives acknowledgement, then arrival notification is transmitted. Receives the acknowledgement and checks whether the acknowledgement is corrupted or not. If it is corrupted, it kept in sleeping condition. Not corrupted and correct acknowledgement number is received, then the stored frame is purged, because the previous frame successfully transmitted, so it purged the frame and window slide over. So SF is reset to next one. And then timer is stopped. Next one, if timeout occurred, then what happened at sender? If timeout occurred, then that event is notified immediately. The timer is stopped and temporarily SF values is stored, and then check whether we reach the last frame or not. Otherwise, if you are not reaching the last frame, then we retransmit the frame and SF value is incremented by 1. This is what happening in the timeout case. And the next one, the algorithm available at receiver. See, there are only one control variable is managed here, Rn equal to 0. Continuous loop and waiting for the event. Only one event is occurred at receiver. What it is? Whenever the frame is received, then arrival notification of the data frame. Is transmitted. Immediately the data link layer at receiver receives the frame and check the frame for correctness, whether the frame is corrupted or not. If it is corrupted, then no acknowledgement is transmitted. Simply the receiver is kept into sleeping mode, and then the sequence number, and also after checking the correctness, the sequence number will be checked. Sequence number equal to Rn. Because it checks whether that the received frame is expected frame or not. If any out of order sequence present here, expected frame is 0 but received frame is 3 other than 0, then simply received frame is discarded. In order to do that, it checks the sequence number of received frame. If it is equal to expected frame, then data is extracted and delivered, and then Rn is incremented by 1, send the acknowledgement for the received frame. This is the algorithm executed at receiver. And then we will see the operations belongs to go back and ARQ. In go back and ARQ, as I said previously, SF, SL2 variables are available, control variables. SF indicates the first and last frames and so on. And then here for receiver concern, only one variable are. So frame 0 received is transmitted and frame 1 is transmitted because two frames are available here. So that two frames are transmitted here, frame 0 and 1. Then send the acknowledgement. See, the acknowledgement case, you should remember that the receiver may send the individual acknowledgement or cumulative acknowledgement. There are two frames received here. For frame 0 and frame 1, it may send a cumulative acknowledgement ACK2, or the receiver is free, then for frame 0 it sends acknowledgement, for frame 1 it may send acknowledgement. For each and every frame is acknowledged, or only cumulative acknowledgement transmitted here. And then frame 2 is transmitted, acknowledgement 3, this is the normal case. And the next operation is, suppose the frame is lost, then what happened? Frame 0 transmitted correctly, frame 1 transmitted correctly, and frame 2 is also transmitted because acknowledgement 2 is received here. Right? Received here. ACK2 is received, so that two frames are excluded and the two new frames are included here, 3, 0. Unfortunately, the frame 2 is lost. The expected frame is 2, but frame 2 is lost here. Then 3 is included at sender. So if any frame available within the window that can be transmitted, so frame 3 is transmitted here. Transmitted frame is 3, but expected frame is 2. That's why we check whether that sequence number is equal to expected number Rn. We are checking any out of order sequence, then the frame 3 is discarded. Frame 3 is discarded here. Frame 3 is discarded. And then if any frame is discarded, it send acknowledgement. Frame 2 is lost, then acknowledgement. The expected frame is 2 and received frame is 2. Then correctly receives the frame and send the acknowledgement and continues in the normal way. Right? And then another important term I want to tell you, piggybacking. Piggybacking. It means, so far what we are discussing means one-way communication. From one end to another end we are sending data frame. In the reverse direction we are not sending any data frame, we are sending only the acknowledgement frame. That is called as simplex transmission. Now we are going to discuss about bidirectional communication. Bidirectional communication, it means both the end. The data is transmitted. Sender to receiver, receiver to sender, data is transmitted. In that case, what is the scenario here? See, sender side completely changed. Receiver side completely changed here. Receiver side completely changed here. See here. No change in the sender side. As I said previously, there are three events raised here. Event, event and event. First one, request to send event, arrival notification event, timeout event. Receiver side, only the arrival notification event alone available in the previous case. Now, the receiver is also able to send the data, so that there are three events exist here. Event to send, event timeout and event for notification, arrival notification. So in that case, data is transmitted in this direction as well as in the reverse direction. Piggybacking, which is nothing but acknowledgement is attached to the data frame itself. At the end of the data frame, acknowledgement is attached with, so that no separate acknowledgement frame is used here. The data frame itself, we are sending the acknowledgement. That case is called as piggybacking. That case is called as piggybacking. So this piggybacking is possible in Go Back N ARQ. Bidirectional communication is possible in Go Back N ARQ. So this is the case. Thanks for listening. Thank you. The next topic we will see in the next session.